but the energy it can unleash is devastating. This is the same energy which keeps the stars alight. All this is from just a single balloonful of hydrogen. The ball of hydrogen that makes a star is 1 million kilometers across. A star releases the energy of millions of H-bombs every second. But far from being destructive, inside the nuclear furnace of every star, there is an extraordinary process of creation.
As I stand here in the bottom of this silo and look up at the thermonuclear device 100 feet above me, if it were to go off, in an instant, I and everything in a 10-mile radius would be evaporated. But in that same instant, it's quite likely that almost every element in the universe would be created. Just as inside stars, hydrogen fuses to form helium, which fuses to form carbon, then nitrogen, then oxygen, silicon, iron. So that as I look around me here, everything I see was once inside of a star. Every atom came from inside of a star.
The universe began with hydrogen. And hydrogen created the stars. And the stars created the elements we need for life. Oxygen in the air, calcium in our bones. It all came from the stars. But how? If it was created there, how did it make our world?
It's astonishing to think that all the ingredients to make the Earth and every living thing were created inside stars. Every star is an immense factory churning out billions and billions of tons of chemicals. But the chemicals aren't much use to anybody while they're in there. Luckily for us, stars don't last forever. Just occasionally, they explode.
Amazing, but true. Entire stars can blow themselves apart. To understand why, let me take you back to the very last few moments of a star's life, just as it teeters on the point of destruction. This is a star that died billions of years ago. It's huge. Its life has been violent and short. And its death made our lives possible. You are about to witness one of the most violent and wondrous events in the cosmos. The star has run out of hydrogen fuel. The nuclear fires that have kept it burning for millions of years have gone out. As it cools, it shrinks. It starts to collapse under its own weight. It crashes inwards and explodes. The whole event is over in 1,000th of a second. They call it a supernova, an explosion so bright it outshines entire galaxies. billions of tons of star stuff hurtle outwards into space. So look at a supernova, and you're witnessing a moment of creation. But even with our most powerful telescopes, these awesome explosions remain frustratingly distant. The best way to find out what really happens when a star dies is up close and personal.
We are now charging. Access for the target shot. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
To understand the moment of creation that happens when a star dies, you have to study the explosion.
So we really are mistimed by 2 nanoseconds.
Yes, we are.
Paul Drake's job is to recreate the most violent explosion in the universe in a lab in upstate New York.
It may not look like it, but this is our version of an exploding star in the lab. Now, exploding stars release a huge amount of energy, and we can't do that here on Earth. We'd blow up the solar system. But what we can do is concentrate a great deal of energy into a small volume.
To generate anywhere near the force of a supernova, Drake uses the world's most powerful laser and focuses it onto a point smaller than the head of a pin.
So here we are in the